All right, so for those of you interested, I have an update to the Tesla autopilot project coming up. All right, so first off, what changed? Well, I upgraded my graphics card from a GTX 1060 6GB to an RTX 2080 Ti 11GB, and the size of the models I'm able to run are much bigger, and I'm able to train them much faster. So that's a big improvement. Now next, you might remember from the last video when I was showing you how I was detecting the lanes. It was very much a programmatic process, and it's just not going to work. See what you're looking at here is an example of that, and it was pretty decent at detecting lanes, but I was also calculating the slope and the curvature, but it was very kind of like a manual thing, and there was a lot of code behind it, and it was just very unrealistic, and it wasn't working, and it was never going to work. So I scrapped the whole thing, and I decided to go with a convolutional neural network. So I'm going to use neural networks through and through for the whole thing. Now, as it turns out, a couple days after I made this decision, Tesla held their Autonomy Day, and that's where they released and went into some of the details behind their full self-driving architecture. And as it turns out, they too use convolutional neural networks, and that's really the driving force behind their lane detection and steering and full self-driving. So this was a happy coincidence. You know, it's funny, Elon also made a comment that they too, I guess, tried detecting the lanes using, a similar approach as I was previously using, and they said it just didn't work and it was a disaster. So I know I'm on the right path here. So now let's talk about the new architecture that I'm implementing here, okay? I'm taking the car camera's output and I'm feeding that to a convolutional neural network that's responsible for predicting the lanes. So the output from that neural network is purely for lane prediction. I'm then taking the output from this neural network and feeding it to another convolutional neural network that's responsible for taking those lane predictions and turning them into steering angles. Now, one of the things you might be wondering is, how am I getting the data to train these neural networks? And the answer is painfully. But let's take a look at how I'm doing this. All right, what you're looking at here are training images. The image on the left is the original image from a camera from the car, the simulated car, and the image on the right is my labeled image. So I have hand-drawn labels on top of these images. The blue lines that you can hardly see, but those represent the lanes. The green represents the path. The purple is obviously the road. And the red are areas where the car cannot and should not drive. Now, initially, I'm only using the blue lines to represent the lanes. Since I was doing this, I went ahead and kind of labeled everything just in case I want to use them later on. But yeah, this is how I'm doing it. Frame by frame, I'm hand labeling the data myself. It's pretty rough, but let's take a look at some of the results. All right, now what you're looking at here is the results of that first convolutional neural network that's just responsible for lane prediction. So what you're looking at here is the images on the top. Those are obviously the frames coming in from the car's camera, and the image on the bottom is the neural network's prediction of where the lanes are. So as you can see, it's doing a pretty good job here. And when I saw these results, I figured I was on the right track. But now let's take a look at what these results are translating to when it comes to automating the car. All right, so what you're looking at here are the results after only 100 training examples. So this is only showing it 100 frames of lanes. And as you can see, the car's unsure of itself. The wheels look a bit wobbly. It's making it somewhat its way around the track, but you can tell it's very unsure of itself. And it kind of gets up this hill, but you'll see very shortly here it goes off the road. But again, this is only after 100 training examples, and as you know, if you've written neural networks before, that's not a lot. So now, the next thing we're going to do is, let's take a look at after 200 training examples. So now you can already see the car's more sure of itself. The wheels are much less wobbly. It made it through that straightaway, and it's making it through this curve with relative ease. Now it's getting to a tough part here. It's crossing the lanes, but in fairness, when I was driving the car to train it, I was crossing the lanes too. It's very hard to keep this car stable. But let me add this. This is the first try. after doubling the amount of training images, and here it goes off the road. But that is the first try. So you can clearly see the more data I feed it, the better the neural network gets at predicting lanes and ultimately predicting the steering. So I think I'm going to keep heading down this path. I think it's in a good place now, and I'm confident with the progress I've made so far. Now, if you remember last time, I was also working on an experimental reinforcement learning algorithm to try to train the car to teach itself how to drive. So I've made some updates to that you can see here. I've trained an inception model so the car can determine if it's in the lanes, if it's off the road, if it's on the road but not in the lanes. And you can see that here in the little display at the bottom. The progress I've made is obviously not great, as you can clearly see here on the screen here, but I think the next steps with this experimental reinforcement learning approach is I'm going to kind of blend these two approaches together and see what I can come up with. But yeah, the results so far are frustrating. But I knew this was going to be a challenging part of this. And again, it's just experimental, so we'll kind of see where it goes. Yeah. All right, so that'll do it. Hope you enjoyed that. And as always, thanks for watching.